Hi everyone, this is Dr. Seshagiri, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I want to discuss about power transmitting systems. In this module, the topics will be covered. One is introduction to power transmission systems and types of transmission systems and types of belt drives and design calculation of belt drives. Coming to the introduction part, generally rotating elements which have mechanical energy. So that energy has to be utilized at a required place by transmitting from one shaft to another. So it means one pulley to another pulley. So the transmitting systems are different types. So what are they? Power transmitting systems we will see. The types of power transmitting systems are one is belt drives and rope drives, chain drives and gear drives. These all are the power transmitting systems. So these drives are used to transmit the energy from one shaft to another shaft. First we will discuss about belt drives. So belt drives are generally used to power is to be transmitted between the parallel shaft. And the belt drives are consist of two pulleys over which a endless belt is passed encircling the both. And rotary motion is transmitted from driving pulley to driven pulley. So I will show you diagram. So in this diagram, see, this is the belt drive arrangement. Here two shafts are there. The smaller one is driven shaft and bigger one is driving shaft. And one endless belt, the endless belt fastened over the pulleys. So one is slack side, another one is tight side. And the pulley, similarly, the driving pulley arranged and driven pulley. So this endless belt is fastened over the driving pulley and driven pulley. So here the rotation is possible from anti-clockwise direction. So it means like this and transfer to the driven shaft. In this rotating in same direction. So one side is called as tight side. So why? Because here tension will be high when compared to the top side. So in this, while rotating, the driving pulley, driving shaft pulls the belt at bottom from the bottom and deliver to the driven shaft. So one time it pulls and delivers. So it means here energy giving and here the driven shaft receiving that energy. So this is the that basic concept of belt drive. So belt drives are classified into different types. So according to their cross section and the arrangement of shafts. One is flat belt drive, another one is V belt drive, and again the flat belt drives are classified into three types. One is open belt drive and crossed belt drive and compound belt drive. So we will discuss one by one. Coming to the flat belt drives, this is the arrangement of flat belt drive. The pulley, driving pulley, arranged on each driving shaft, and the driving shaft, the belt arranged on a driving shaft is the flat belt. So why? Because the cross section of the belt is here rectangular. So here the driving pulley, driving shaft and driving shaft rotating in a same direction. This one also rotating in clockwise, and this pulley, this shaft also rotating in clockwise direction. And one more thing is here, this flat belt in this driving shaft pulls the belt at bottom, and here giving that belt to driving pulley. So that means the driving shaft receives that belt. So as we discussed in belt drive basic concept. So this type of flat belt drives are generally used in industries and workshops. And the distance between these two pulleys or two shafts is the maximum 8 meters. Up to 8 meters apart only these type of belt drives are used. Again, the flat belt drives are classified into two types. One is open belt drive, and the second one is crossed belt drive. So this is the difference in arrangement of belt. See, in this open belt drive, this one is the driven pulley. So diameter is D1, driving, and second one is driven. Diameter is D2, and rotational speed is N1, and rotational speed is N2. And one side is this one is slack side, and this one is tight side. These both shafts are rotating in same direction. And the second, the cross belt drive, the belt is crossed over the pulleys. So this one also similarly D1 N1 and D2 N2. Rotational speed is N2. Here see, this driving shaft is rotating in clockwise direction, and this one is anti-clockwise direction. The driving pulley and rotating in anti-clockwise direction. So it means is rotating in opposite direction. So in this first case, the two shafts are rotating in same direction, but whereas in cross belt drive, the shafts are rotating in anti-clockwise direction. That means opposite direction. So one is here slack side, and second one is tight side. So more tension will be occur at tight side. So next one is compound belt drives. These type of belt drives are, so wherever required more power transmission. So it means power transmitted with the number of pulleys. So here see, one driver and driven, again driver and again driven. Here two drives are connected. So these type of belt drives are called as compound belt drive. So it gives more power transmission. Next classification is V belt drive. So the V belt drive is made with the corks and rubber in a trapezoidal form. So that the cross section on the belt is here shown here. So this is the cross section of the belt, and this is the angle of the V belt. So it means here the angle is 2 beta. This is the groove angle. So V belts are generally used for short drives. So it means whenever the distance between the two pulleys is very short, at that time the V belts are very useful, and wherever required more power transmission, so their V belts are very useful. These type of V belts also used in factories and workshops. So only difference is the cross section of the belt, and it gives more strength also. So generally the angle is 30 degrees to 40 degrees. This is a groove angle of the V belt. This is the arrangement of V belt drive. See here, once again we will see the classification of belt drives are flat belt drives and V belt drives, and third one also there, that is circular belt. So the flat belt drives, see the cross section is a rectangle, and V belt drive the shape is the trapezoidal shape, and this is a round one, the circular. This type of circular belt is used for long distance drives. So that is means greater than 8 meters distance. In this, we will see design calculations. For designing a belt drive, so we have to do some calculations like the velocity and power transmission and the tensions ratio. So, and what is the thickness of the belt and width of the belt? By using these formulas, we can do. The first one is the velocity. The velocity of the belt on the driving pulley, and similarly on the drive-in pulley. The first one is the driving pulley, that is pi d1 n1 by 60 meters per second. So where here already you know the d1 is the diameter of the driving pulley, and n1 is the rotational speed of the driving pulley. And similarly the v2, so pi d2 n2 by 60. So d2 is the diameter of the driven pulley, and n2 is the speed of the driven pulley. So when there is no slip, then v1 is equal to v2. So we can write finally the velocity ratio is n2 by n1 is equal to d1 by d2. So here I want to discuss about slip. So what do you mean by slip? Generally, some coefficient of friction between the belt and pulley. Sometimes this coefficient of friction is not sufficient to grip the belt. So that time the belt moves forward without gripping of belt. This type of phenomena is called as slip. If you are not considering slip, so directly you can equate the velocity of on the driving pulley is equal to velocity on the driven pulley. So with considering slip, we will tell. We will see in the next slide. So in case of compound drive, the already shown in figure in the previous, the velocity ratio is given by here n4 by n1 is equal to d1 by d2 multiplied with d3 by d4. So why? Because here total 4 drives are there. So the speed of last driven divided by the speed of first driver, and the product of diameters of drivers divided by product of diameters of drivens. So we will get this n4 by n1. This is the velocity ratio. So the relative motion between pulley and the belt passing over, it is defined as slip. Already I told you. So when slip is considered, n1 by n2 is equal to d2 by d1. So multiply with 100 by 100 minus s. So this is the slip percentage. Next, length of open belt drive. So by using this formula, you can calculate the length of open belt drive. This formula also available in our design data handbook. You can refer any design data handbook. So here mentioned here open belt drive is 5 into R1 plus R2 plus 2x plus R1 minus R2 whole square by x. So what is here x as shown in figure? This is the center distance between the pulleys, and the R1 is the radius of the driving pulley, and R2 is the radius of the driven pulley. So this is the angle of contact, the R1 minus R2 by x. This is the velocity ratio. So here angle of contact is very important while designing a belt drive. The power transmission is depends upon the velocity ratio and the arc of contact. The next one is the length of crossed belt drive. So that the length of crossed belt drive, so 5 into R1 plus R2 plus 2x plus R1 plus R2 whole square by x. So the only difference is this R1 plus R2 whole square. So in the case of open belt drive, so R1 minus R2 whole square. So negative sign, here positive sign. And the alpha, the angle of contact is R1 plus R2 by x. The diagram shown here, this is the center distance, and this is the angle of contact. So angle of contact or arc of contact means, so how much belt portion embraced with the pulley surface. So that is called as the arc of contact. Next is the ratio of driving tensions for a flat belt drive. So this is the T1 by T2 is equal to e to the power of mu theta. So here T1 is the tight side tension, and T2 is the slack side tension. And mu is the coefficient of friction, and theta is the arc of contact. You can write like this also, T2 is equal to T1 by e to the power of mu theta. And relation between the maximum tension and strength of a belt. So here when centrifugal tension is considered, so that equation is T is equal to T1 plus Tc. So here the centrifugal tension, you have to add. So then the relation will get the T is equal to T1 plus Tc. T1 already know tension in the tight side of the belt, and the total capital T is maximum stress multiplied with cross-sectional area of the belt. This is the T, sigma into B into T. B is the width of the belt, and T is thickness of the belt. And the maximum shape stress have to take from a design data book, that is depends upon the belt material. So here Tc is equal to mv square. So this is the centrifugal tension. So some centrifugal tension will act on a belt drive. The next one, condition for maximum power transmission. So what is the condition? So you have to derive. So here the power transmission equation is P is equal to T1 minus T2 multiplied with V. So T1, T2 already know. The V is the velocity of the belt in meters per second. And the tensions ratio also, you know, T1 by T2 is equal to e to the power of mu theta. So substitute these two value substitute the T1 by T2 value in power equation. So this is the equation 1. So substitute in equation 1, you will get the relation like this, T1 into V into C. So here you can write the entire term, the 1 minus 1 by e to the power of mu theta in terms of C. So substituting the all values, you will get one relation equation, that is T into V into mv cube multiplied with C, that is constant. Tc is mv square, that is centrifugal tension. For maximum power transmission, differentiate the above expression with respect to V. So that is dp by dv. So then you will get one relation, that is T is equal to 3Tc. So this is the the condition for maximum power transmission. So it means the maximum power transmission, the T, the capital T, that is the tension, is equal to the centrifugal tension is equal to 1/3 of the maximum tension in the absorbed is centrifugal tension. Next one is in the case of V belt drive, the driving tension ratio is T1 by 2.3 log T1 by T2 is equal to mu into theta cosecant beta. This is this relation in terms of base 10. So in terms of E anti-log T1 by T2 is equal to e to the power of mu theta into cosec beta. So here T1, T2 already know tight side tension and slack side tension, and mu is the coefficient of friction, and theta is the angle of contact, and here B is the groove angle. So already I told you that 2 beta is generally for E belt is 30 degrees to 40 degrees. So that B is equal to, beta is equal to 30, you can take 30 by 2, 15 to 20 degrees. So this is the calculation part of a belt drives. So I have taken these are references. You see Jindal Machine Design and R.S. Kurmi and J.K. Gupta, and the data book is K. Mahadevan and Balvira Reddy. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.